So for a long time, there's been this, well, this kind of unspoken tension in the hard sciences.
Absolutely.
Yeah, it's like this artificial line drawn right down the middle of how we understand reality.
Yeah.
On one side, you have fundamental physics.
Right. Clean stuff.
Exactly. It's a domain defined by this severe, almost austere elegance. You're dealing with the standard model, general relativity, quantum field theory. The math is just pristine. You have symmetries, you have conservation laws, and, predictable thermodynamic decay.
Yeah, you can calculate the decay rate of a proton with staggering precision.
Right, or the orbital mechanics of a gas giant.
Yeah.
It really feels like you're looking at the bare metal of the universe.
Well, yeah, because physics is inherently reductionist. And, I mean, I don't use that word pejoratively.
No, sure.
Its primary methodology is isolation. You isolate a variable, you strip away all the environmental noise, and you define the immutable rule governing that specific interaction.
Right.
So it's highly deterministic at the macro scale and, probabilistically exact at the quantum scale.
But then, and this is where it gets wild for you as a learner diving into this stuff,
Yeah.
you pan over to biology, and that pristine reductionism completely falls apart.
Completely. It just breaks down.
Yeah, you look at a cell or like a ecosystem or embryonic development, and the math isn't clean anymore. Biology is just notoriously messy.
It's a landscape of highly contingent, highly localized phenomena.
Exactly. You're dealing with emergent properties, misfolded proteins, horizontal gene transfer, just the sheer chaotic noise of evolutionary pressure. And for centuries, the implicit assumption has basically been that physics is the foundational rulebook.
Right. Yeah.
And biology is just this weird, highly improbable accident that somehow occurred on top of it, like a localized chemical anomaly that managed to temporarily cheat thermodynamic equilibrium.
Which is, frankly, an incredibly bifurcated way of looking at existence.
Yeah.
I mean, it treats living systems as strangers in their own universe.
Wow, yeah. Strangers in their own universe.
Exactly. We've essentially been operating under this assumption that matter obeys one set of fundamental laws, while life through, some combination of blind luck and sufficient time.
Right, the infinite monkeys with typewriters idea.
That life managed to cobble together a completely different ad hoc set of operational rules using the raw materials physics provided.
And that tension, that exact disconnect, is why Philip Lilien's 2026 paper is causing such an earthquake right now.
Oh, it's a massive paradigm shift.
It really is. The paper is called Panspatial Genesis and the Hyperfractal Architecture of Life, published by the UCTE Foundation. And we're doing a deep dive into this paper today because it completely obliterates that artificial line.
It absolutely does.
Lilien is arguing that biology isn't a freak chemical accident at all. He says it is an absolute mathematical inevitability.
Yes.
The thesis is that life is simply the hyperfractal continuation of physics.
It's a profound ontological shift. I mean, think about standard origins of life research.
Abiogenesis.
Right, abiogenesis. It is obsessively focused on local chemistry.
Yeah, ask questions like, what was the exact concentration of ammonia and methane in the Hadean Oceans, right?
Exactly. Or, did RNA form in hydrothermal vents, or was it in shallow tidal pools?
Right.
But Lilien steps back and argues that those are secondary, almost trivial questions.
Wait, trivial?
Well, in the grand scheme of the architecture, yes. He proposes that we should be asking a much deeper structural question. What underlying topological and physical architecture must exist in the universe for a self-maintaining boundary to emerge in the first place?
Okay, wow. Which brings us to the core thesis of the paper. He maps this out with a central formula, and I want to lay it out here for you right at the top because we're going to be referring back to it as we go.
But the roadmap for the whole paper.
Exactly. So the equation is this. C subscript F CHP plus ACO plus H subscript F of A plus B subscript recursive plus M subscript L yields L subscript min.
And look, I know that might look totally impenetrable right now.
Oh, it sounds like absolute alphabet soup. Okay, let's unpack this.
Well, the elegance of Lilien's work is that each of those variables represents a distinct logical threshold. He's formalized the physical conditions required to organize fundamental asymmetry into a bounded, living identity.
Okay, so I want to start by looking at where this process actually happens.
Yeah.
Because the paper argues that you can't just have life emerge anywhere, even if all the chemical building blocks are present.
Right, there are structural prerequisites.
Yeah, and Lilien introduces this concept of the middle regime,
Yeah.
or he also calls it the ontological nursery.
Yes, the ontological nursery. To understand this, you really have to consider the thermodynamic and spatial extremes of physical systems.
Okay, let's look at the extremes.
Take the extreme of pure openness. Think of a dissipating nebula or a highly turbulent gaseous environment.
Just a cloud of stuff expanding into a vacuum.
Exactly.
Mhm.
In a state of pure openness, there are no stable topological boundaries. Any gradient, like a temperature difference or a chemical concentration, it's rapidly smoothed out by entropy.
Right, because there's nothing holding it together.
Right. Structures might form fleetingly due to stochastic fluctuations, but they are instantly washed away. The environment is simply too fluid to retain memory or identity.
I think of it like working with clay, you know. If it's pure liquid, like a soup, you just can't mold it. It won't hold a shape. You
Yeah.
can't build a complex system if the foundation is constantly evaporating.
That's a great analogy, but the opposite extreme is equally hostile to life.
Complete spatial closure.
Precisely. Rigid, absolute closure is the domain of perfect crystals. Take the atomic lattice of a diamond, for example.
Okay, so a diamond is totally solid.
The boundary is absolute, the identity of the structure is completely preserved, but it's completely static.
Right.
A fully closed system has 0 degrees of freedom. It cannot adapt to novel stimuli, it cannot process external information, and crucially, it cannot metabolize.
Because nothing can get in or out.
Exactly. It cannot exchange matter or energy with its environment in a regulated way. A diamond is perfectly preserved, but it is entirely dead.
Going back to the clay analogy, it's like a brick that's already been fired in the kiln. You can't change it anymore. So life needs the wet clay. It needs a physical state that avoids both rapid dissipation and rigid fossilization.
Partial closure.
Right, partial closure. And Lilien specifically locates this in something he calls the ACO band. This is the ACO variable in our master equation.
The atomic continuum ontology band.
Yeah.
Now, this is where Lilien's math gets incredibly dense.
Oh, yeah, the paper gets really heavy here.
But the conceptual takeaway is vital. He defines the ACO band mathematically as an interval between 3.14D and 3.0D.
Okay, wait, I want to stop you right there, because that's the kind of notation that usually trips people up. When he says 3.14D, he's not talking about three-dimensional space plus a little bit of a fourth dimension, is he?
No. Not
We're talking about fractional dimensions, right? Hausdorff dimensions.
Exactly. We're deep in the realm of fractal geometry and topology here. A perfect 3.0D space represents stable spatial closure.
Like the diamond.
Yes, discrete, bounded, three-dimensional objects. But the 3.1 for D end of the interval represents what he calls coherence curvature equilibrium.
Coherence curvature equilibrium. What does that actually look like?
It's a state of pure generativity, a mathematical space that is highly dense with potential connections, but hasn't yet collapsed into rigid, isolated forms.
No, so the ACO band isn't like a place you can point a telescope at.
No, it's a phase space.
Right, it's a transitional interval where the raw phenomena of the universe are structured but incomplete. And the paper lists a few things that naturally occur in this specific nursery interval, like turbulence, fractal recursion, quantum partial closure. But I want to push back on something here, because turbulence is notoriously chaotic.
It is.
So how does turbulence play a role in setting the stage for life? Doesn't it actively destroy structure?
Standard turbulence destroys rigid structure, yes. But within the constraints of the ACO band, turbulence is what provides the system with raw asymmetry.
Asymmetry.
Think about it. If a universe were perfectly uniform, nothing would ever happen. You need symmetry breaking. Turbulence stirs the system, creating localized differences in energy, density, and charge.
Okay, so it shakes things up.
It generates transient, highly complex structures, eddies, vortices.
But an eddy in a stream dissipates. It doesn't become a cell.
It doesn't become a cell, no, but it creates the absolute prerequisite condition, boundary preformation.
Oh, I see.
When a vortex forms in fluid dynamics, it temporarily establishes an inside and an outside.
Right. The water inside the whirlpool is moving differently than the water outside of it.
Exactly. The fluid inside the vortex is operating under different local vectors than the fluid outside. It's a proto-boundary. It's not biological. It obviously has no membrane. But topologically, it has localized a distinct region.
Wow.
The ACO band allows these pre-objective potentials to exist long enough to interact without immediately freezing or dissipating.
That makes so much sense. So it's connecting back to our understanding of reality.
Hmm.
Standard physics looks at a rock and says, that is matter. It has achieved stable 3.0D closure.
Yes.
But life is matter that is suspended in this partial closure state. It has to constantly work to maintain its boundary without fully closing it off.
Matter is closure achieved. Life is closure maintained.
I love that.
That distinction is the beating heart of Lilien's thesis. The ACO band provides the necessary state of bounded openness, but as you rightly pointed out, a transient vortex is not alive.
Right. It vanishes.
It lacks functional persistence, which leads us directly to the mechanism that can capture that transient asymmetry and stabilize it.
Okay, yes. The bridge from chaos to order. And this is the H subscript F of A in our equation, the hyperfractal resonance operator. Now, I really want to spend some time here because the word fractal is thrown around a lot in popular science, usually to describe like Romanesco broccoli or the Mandelbrot set.
Right, pretty geometric pictures.
Yeah, exactly.
Right.
And a standard fractal is scale invariant. You zoom in on the shape and you see the same shape infinitely repeating.
Yeah.
But Lilien is very careful to distinguish a fractal from a hyperfractal.
It's a critical difference. A standard fractal merely organizes geometry across scale.
Just the shape.
Just the shape. A hyperfractal organizes function across scale, phase, gradient, and boundary depth. To put it another way, standard fractals are structurally self-similar. Hyperfractals are operationally self-similar.
Okay, so I'm visualizing this. A standard fractal is like a Russian nesting doll that just looks identical all the way down, right?
Sure.
But a hyperfractal would be if the mathematical relationship that dictates the shape of the small inner doll is actually actively powering and repairing the outer dolls.
That's a very sound way to conceptualize it, actually.
Right.
Yeah. The hyperfractal acts as an admissibility filter. It engages with the raw, chaotic noise of the ACO band, the turbulence, the fluctuating gradients, and it selects only the asymmetries that are compatible with self-maintenance.
So it's filtering out the noise that would destroy it.
Yes, it uses a mechanism called coherence resonance. It takes stochastic noise and instead of letting it degrade the system, actually uses the energy of that noise to stabilize the system's internal frequency.
Capturing chaos and putting it to work. That is wild.
It is.
And Lilien provides a fascinating, highly specific example of this in the paper that I think perfectly grounds this abstract math. He tackles molecular chirality.
Yes. Handedness.
Right. Homochirality is one of the classic puzzles in biology. Like, why do all living things on Earth exclusively use left-handed amino acids and right-handed sugars?
It's a huge question.
Yeah. And the standard chemical explanation has essentially been that it was just a frozen accident, like a primordial coin flip. Millions of years ago, a pool of left-handed amino acids just happened to gain a slight numerical advantage, and evolution just ran with it.
It's treated as an arbitrary historical contingency, but Panspatial Genesis rejects that completely.
Totally throws it out.
What's fascinating here is that Lilien traces homochirality down to what he calls the infratere. He points to fundamental physical asymmetries like parity violation in the weak nuclear force or raw pre-chemical physical torsion.
Torsion being just a fundamental directional twist in the fabric of physical space itself.
Correct. A basic physical asymmetry. And what the hyperfractal operator does is capture that underlying infratere torsion.
Okay.
It acts as a resonance chamber, amplifying and stabilizing that raw physical twist until it becomes a stable chemical property, molecular handedness.
Wow.
But it doesn't stop there. The hyperfractal, by definition, propagates function across scales.
And this is the part that genuinely challenged my understanding of biology when I read the paper. Lilien shows how this initial subatomic torsion cascades upward. It starts as chemical handedness, but the hyperfractal scales it up to dictate the asymmetrical structure of the lipid membrane itself.
Right.
And then it scales up again to establish the internal polarity of the entire cell, like where the organelles are physically distributed.
Yes.
Then, astonishingly, it scales up again to dictate the macroscopic developmental direction of an embryo. The physical orientation of cell division is basically a mathematical echo of that initial infratere torsion.
It completely inverts the standard biological narrative.
Really does.
Life isn't imposing order on a neutral, symmetrical universe. Life is the mechanism by which the universe's fundamental inherent asymmetries are amplified and organized into complex functional systems.
Right.
The hyperfractal operator takes a raw physical quirk and elevates it into a non-negotiable biological rule. Handedness isn't a chemical accident, it's a fundamental feature.
Okay, so once that asymmetry is organized and scaled up by the hyperfractal, it has to be contained, right?
Exactly.
The system has to differentiate itself from the surrounding environment. Which brings us to the next part of the equation. B subscript recursive boundary stratification.
The boundary is where the abstract mathematics of the hyperfractal operator finally hit the gritty reality of thermodynamics.
Right, life's first interface. Now, when you hear boundary, you probably think of a cell wall or a lipid membrane.
Standard biology often conceptualizes the boundary merely as a wall, a bilayer that keeps the inside in and the outside out.
Yeah, the traditional view is that the membrane is just a container. You have
Yeah.
the wall and all the alive stuff, the DNA, the ribosomes, the metabolism, all of that happens inside the container.
But Lilien insists that a container that merely encloses is thermodynamically dead.
A dead wall.
Exactly. A rigid separation is no different from the diamond crystal lattice we discussed earlier. A living boundary must be an active, continuously sustained process.
Right.
He introduces the concept of a stratified boundary composed of 7 distinct, simultaneously operating layers that mutually reinforce one another.
Okay, let's walk through these 7 stratas because I found the interdependency between them fascinating. It's not a hierarchy, it's a recursive loop.
Yes, a nonlinear cycle.
He starts with the geometric stratum.
The geometric stratum is the baseline topology. It defines the physical shape, the internal volume, and the surface area to volume ratio of the system.
Basically the physical footprint.
Right, the physical footprint required to interact with the environment.
But geometry alone doesn't really do anything. Like, a plastic bag has geometry, which leads to the second layer, the chemical stratum.
Yes, the topology of the geometric layer physically allows for the formation of the chemical stratum, which governs selective permeability.
Selective being the key word.
Exactly. This isn't just about blocking molecules, it's about establishing highly specific gated channels. The boundary must actively decide what to import, what to retain, and what to expel based on the system's immediate needs.
And that chemical selectivity is what makes the third layer possible, the electric stratum. Because if you can selectively pump ions like sodium and potassium across your geometric barrier, you create a charge differential.
You build up a membrane potential.
You've basically built a battery.
You have. The electric stratum maintains the charge distribution, which is a state of severe thermodynamic tension.
Right.
And that tension, that stored electrical energy, is the absolute prerequisite for the fourth layer, the metabolic stratum.
We're going to do a much deeper dive into metabolism in a second, but in the context of just the boundary, the metabolic stratum is where that electrical tension is utilized to drive energetic fluxes.
No, it's the engine room operating right at the border.
And that metabolic engine powers the fifth layer, the informational stratum.
And note that this isn't just DNA.
Oh, right.
In Lilien's framework, information is the active maintenance of the distinction between signal and noise. The boundary must process external stimuli, decode chemical gradients, and transmit that data to the internal architecture.
It's like the sensory layer,
Right.
which is necessary for the sixth layer, the repair stratum. And I think this is where standard membrane models fail the hardest.
Absolutely.
Because a lipid vesicle might form spontaneously in a lab, but if it takes thermodynamic damage, it just bursts.
It pops like a soap bubble.
Right. But a living boundary detects its own degradation and initiates localized restoration. It metabolizes energy specifically to patch its own geometry.
Which culminates in the 7th and most philosophically complex layer, the identity stratum.
The identity stratum.
The identity stratum is not a physical substance. It is the overarching dynamic attractor state that preserves the system's pattern continuity over time.
This is the classic ship of Theseus problem, isn't it?
Yeah, it's perfectly the ship of Theseus.
Because
Right.
a cell is constantly swapping out its carbon and nitrogen atoms with the environment. The actual physical material of the boundary is entirely replaced over a given time frame, yet the functional pattern in the identity remains coherent.
And the loop closes. Because it is that preserved identity that dictates the future regulation of the geometric stratum.
Wow.
It is a completely self-referential, closed loop of causality. Shape enables chemistry. Chemistry builds electric potential. Electricity drives metabolism. Metabolism processes information. Information directs repair. Repair sustains identity, and identity dictates shape.
It's a literal Ouroboros, but one that is constantly pulling new material into its cycle to keep spinning.
Yes.
And Lilien condenses this massive complexity into a surprisingly simple subformula for minimal life admissibility. B subscript L equals D plus S plus G plus R plus I.
Distinction, selective exchange, gradient maintenance, repair recursion, and identity continuity.
If a system possesses these 5 interacting properties, regardless of its chemical substrate, it fulfills the topological requirements for a living boundary.
Exactly. It's alive.
Okay, I want to zero in on the G
Yeah.
in that subformula, gradient maintenance.
The engine.
Right, because this recursive boundary is mathematically beautiful, but it operates in a universe governed by the second law of thermodynamics. Entropy is relentless.
Entropy always wins eventually.
Right. The universe wants to break down that electrical gradient. It wants to equalize that chemical imbalance. It wants to shred that geometric topology. To maintain that boundary requires constant directed work.
And that requires power.
Which brings us to the M subscript L in the core equation, metabolism. And here, Panspatial Genesis completely redefines what metabolism fundamentally is. Because if you open a standard biochemistry textbook, metabolism is just defined as the sum of all chemical reactions that occur within a living organism.
It's treated as a complex, highly regulated chemical fire.
It's basically viewed as an engine. You put glucose in, you run it through the Krebs cycle, and you get ATP out. It's an input-output chemical factory.
And Lilien views that as a dangerously reductionist definition.
Dangerously reductionist.
Yes, because it misses the forest for the trees. He defines metabolism not as a set of chemical reactions, but as a hyperfractal temporal operator.
Okay, temporal operator.
Metabolism is the functional process of converting external spatial asymmetry, like thermodynamic gradients, into internal temporal coherence.
Converting external asymmetry into internal coherence is a very abstract phrase. Let's unpack it. If life is a sustained state of partial closure, it means it is inherently unstable.
Rare and stable.
If it stops working, it dies.
Think of a dissipative structure in physics, like a hurricane or a convection cell in a pot of boiling water.
Okay, boiling water.
These structures spontaneously self-organize when a system is pushed far from thermodynamic equilibrium. A hurricane is a highly ordered geometric structure that exists solely to dissipate a massive temperature gradient between the ocean and the upper atmosphere.
Right.
It intakes energy, creates a complex structure, and exhausts entropy.
Right, but a hurricane isn't alive. I mean, it has a geometric boundary, it intakes energy, it even has a kind of identity. We name them.
We do.
But when the temperature gradient vanishes, when the hurricane hits land, it simply ceases to exist. Yeah. It has no mechanism to sustain itself.
Exactly. A hurricane is entirely at the mercy of the external gradient. Lilien argues that metabolism is the evolutionary leap beyond a simple dissipative structure. Metabolism doesn't just ride the gradient, it captures it.
It captures the gradient.
Through recursive boundary stratification, the living system channels a fraction of the energy it dissipates back into the structural maintenance of the boundary itself.
It's the surfer analogy, isn't it?
It is.
Like a piece of driftwood rides a wave, a gradient, but it's just passively being moved by the asymmetry of the water.
Right.
But a surfer uses the kinetic energy of the wave to actively adjust their balance and maintain their position.
Yes, but Lilien's concept of metabolism goes even one step further than that.
Right. It would be as if the surfer were actively using the energy of the wave to synthesize new fiberglass to repair microfractures in the surfboard while riding it, so you don't sink.
That is the perfect way to visualize it. It is the localized suspension of thermodynamic decay through continuous recursive labor.
And this energy extraction happens vertically, right? Across what the paper terms the coherence gradient ladder.
The coherence gradient ladder, yes.
Explain that. What does vertical extraction actually mean in this context?
Well, in a simple non-living chemical reaction, energy moves horizontally. It transforms from one chemical state to another, losing some energy as heat.
Just spreading out.
But a living boundary moves energy vertically up the scale of coherence. It takes a lower order difference, like a simple variance in proton concentration outside the cell versus inside, and elevates it.
Okay.
The boundary selectively allows protons to flow back in, but forces them through a topological turbine, like ATP synthase.
So a purely spatial chemical gradient is elevated into mechanical kinetic energy. It literally spins a molecular motor.
Exactly. Which is then immediately converted into stored chemical energy in the form of ATP.
Up the ladder.
And then that ATP is utilized to fold complex proteins, which is structural information.
Higher still.
Those proteins are deployed to the membrane to repair lipid oxidation. Energy climbs the ladder from raw environmental variance to structural identity maintenance.
So metabolism isn't just generating power, it's generating time.
Yeah.
The boundary gives the system spatial distinction. But metabolism gives the system temporal continuity. It allows the system to persist across time by constantly offsetting its own degradation.
Which brings us to Lilien's ultimate definition of life itself.
Right.
Life is not a thing made of specific carbon-based molecules. Life is a mathematically sustained state of maintained disequilibrium.
Maintain disequilibrium.
Because true equilibrium is death.
Absolutely. When a system reaches thermal, chemical, and electrical equilibrium with its environment, it has lost all gradients.
It's flatlined.
It has no potential energy to perform the work of boundary repair. It collapses from bounded openness back into unstructured openness.
It just becomes part of the background noise. And, this entirely reframes how we look at the origins of life.
Completely.
Because standard abiogenesis is so highly focused on local chemical pathways. We spend decades arguing over the specifics, like, was it a metabolism-first scenario in an alkaline hydrothermal event, or was it a replication-first scenario driven by RNA polymers in a drying puddle? And Lilien doesn't dismiss Earth's chemistry, to be clear.
Right. He's not saying the chemistry didn't happen.
No, but he demotes it. If we connect this to the bigger picture, he argues that standard biology is confusing the local material realization with the global structural architecture.
Okay.
Earth's specific mixture of carbon, water, and nucleic acids just happened to be the local building materials that were thermodynamically capable of fulfilling the mathematical requirements of recursive boundary stratification.
Right. To use an analogy, it's like standard origins research is endlessly arguing over whether the first house was built out of clay bricks or wooden logs.
Yes.
And Lilien is coming in and saying the material doesn't matter. What matters is the invention of the arch, the load-bearing wall, and the concept of an enclosed volume.
Yes.
Panspatial Genesis is the physics of the architecture.
And because of this architectural perspective, Lilien is able to take the four major competing theories of abiogenesis and synthesize them.
Oh, this was brilliant.
He shows how they are each looking at isolated fragments of the hyperfractal operator.
Let's walk through that matrix. Let's start with the metabolism first model, which is usually championed by researchers looking at iron-sulfur clusters.
Right, the idea that life started as spontaneous, self-sustaining chemical reaction networks on the surface of rocks, long before DNA or cell walls ever existed.
But Lilien reframes this.
He does. He points out that a naked chemical reaction network, no matter how complex, cannot achieve identity continuity.
Because it's open.
It has no geometric or repair strata. So he reframes metabolism not as the origin itself, but as the inevitable requirement for gradient maintenance once a proto-boundary forms.
The reactions only become life when they loop back to repair the topology that houses them.
Exactly.
Okay, then you have the replication first model. The idea that life began the very moment a molecule became capable of catalyzing its own exact copy.
A powerful local mechanism, certainly, but Lilien argues it puts the cart before the horse.
How?
Replication is merely the extension of boundary identity across generational time. But before you can copy an identity, you must first have a topologically distinct identity capable of maintaining itself against entropy.
Right. A naked replicator in an open environment rapidly succumbs to the error catastrophe.
It mutates into noise.
Because it lacks the informational and repair boundary strata. It can't fix its own errors.
Precisely.
Okay, what about the membrane-first hypothesis? The idea that amphiphilic molecules, lipids, naturally form little bubbles or vesicles in water. Some researchers argue these bubbles were the first step, providing a protected environment for chemistry to happen inside.
Here, Lilien is quite brutal.
He really goes after this one.
He mathematically demonstrates that a simple lipid vesicle is a dead wall.
The diamond again.
Yes. It achieves spatial closure, but it lacks partial closure. A passive bubble cannot selectively import nutrients or expel waste. It cannot maintain an electrical gradient.
So it's a thermodynamic dead end?
Unless it is instantly colonized by a hyperfractal process capable of establishing selective exchange and repair.
Right. And finally, the heavy hitter, the RNA world hypothesis. This is the prevailing consensus, right? That RNA, because it can both store genetic information and act as an enzyme to catalyze reactions, was the sole spark of life.
The RNA world is perhaps the most advanced local realization, but Lilien reframes the concept of information entirely.
Yes, tell us about that.
In Panspatial Genesis, biological information does not begin as a sequence of complex genetic code. It begins functionally as boundary-regulated difference.
Meaning what?
The very first bit of biological information is the active distinction between inside and outside, between signal and thermodynamic noise.
Wow.
RNA is incredibly efficient, but it's ultimately just a highly evolved, localized chemical medium for storing the maintained asymmetry that the boundary demands.
It is the hard drive, not the operating system.
Exactly.
This is the paradigm shift. If you accept Lilien's math, life is not a freak occurrence.
Not at all.
It isn't a statistical anomaly where millions of random chemical variables just happen to align perfectly in a primordial soup. Life is a conditionally universal attractor state.
An attractor state is a condition that a dynamical system naturally evolves toward over time.
Right.
Lilien's equations suggest that wherever the universe presents the right coherence conditions, the partial closure of the ACO band, raw physical asymmetry like torsion, and steady thermodynamic gradients, the underlying architecture of space itself favors the emergence of a recursive boundary.
The universe wants to organize.
It's structurally favored.
Okay, let's tie this entire journey back to that central formula we introduced at the beginning. C subscript FCHP plus ACO plus H subscript F of A plus B subscript recursive plus M subscript L yields L subscript min. We can actually read it as a narrative now.
We really can. In a universe possessing the correct fundamental constants and coherence conditions, that's the C subscript FCHP.
Within a localized phase of partial closure where matter is structured but not static, the ACO band.
If a hyperfractal resonance operator can capture and amplify raw physical asymmetry, the H subscript F of A.
And organize that symmetry into a topologically closed but thermodynamically open system with 7 mutually reinforcing layers of self-repair, the B subscript recursive.
That actively channels environmental gradients into internal structural maintenance to stave off thermodynamic equilibrium, the M subscript L.
You mathematically guarantee the emergence of minimal life, L subscript min.
Yeah.
It is a topological inevitability.
It forces us to completely reevaluate our position in the cosmos.
It really does, because, standard science often leaves us feeling like biological anomalies.
The fragile, highly improbable wetware clinging to a rock in a cold, dead universe governed by unfeeling physical laws.
Exactly. But Panspatial Genesis says exactly the opposite. You are not an anomaly fighting against the physics of the universe. You are an active hyperfractal continuation of it.
Biology is what physics does when it encounters a gradient it can internalize.
You are the universe's own fundamental torsion, hyperfractally scaled up into a macro structure, looking back at itself.
And that leads to an unavoidable, staggering implication regarding our search for extraterrestrial life.
Oh, man. I didn't even think about aliens until the very end of the paper.
We currently spend billions of dollars pointing spectrometers at distant exoplanets, right? Desperately looking for oxygen, water vapor, methane. We are looking for Earth-like chemical signatures.
We're looking for our specific local building materials, the clay bricks.
Exactly. But if life is an architectural necessity rather than a chemical fluke, we may be looking for the wrong things entirely.
Wait, really?
Think about it. If carbon and water are just one localized way to achieve recursive boundary stratification, what are the others?
Oh, wow.
Could there be life-admissible systems operating in the magnetic plasma fields of a star?
Plasma life.
Could there be hyperfractal identities sustaining themselves in the hyperdense, turbulent atmospheres of gas giants, using thermodynamic substrates we can barely conceptualize?
So if an entity in a Jovian atmosphere has achieved geometric topology, selective exchange, gradient maintenance, repair recursion, and identity continuity using, like, atmospheric friction and pressure gradients instead of ATP.
It is alive.
It's alive. We might be looking right at it through our telescopes and dismissing it as just a storm or just weather.
Because it doesn't leave a biological carbon footprint.
We've been looking for chemistry when we should be looking for hyperfractal topology.
Exactly.
And that is a vast, slightly terrifying, but completely beautiful universe to contemplate.
It gives you a lot to chew on.
It certainly does. Thank you for joining us on this deep dive.